We're seeing a universe we've never seen before. We thought it was there, we hoped it was there, but now we see it for the first time.
When scientists pointed the James Webb Space Telescope toward one of the quietest corners of the sky, nobody expected what came next. A team at the University of Missouri uncovered 300 bizarre objects, so bright, so intense, that they simply shouldn't exist. Immediately, the researchers gave them a cautious title, Candidate Galaxies. And if these really are galaxies sitting at the edge of time itself, then we're staring at something that could rewrite the opening chapters of the universe. Because here's the strange part. These objects appear to have existed when the universe was only a few 100 million years old. According to every standard cosmology textbook, this era should have been a slow, dim period when the first stars were barely beginning to flicker to life. Yet here they are, glowing like lanterns in a universe that wasn't supposed to be ready for them. To even identify these 300 cosmic suspects, astronomers used a clever trick called the dropout technique, looking for objects that appear in redder wavelengths but completely disappear in blue ones. It's like watching a magician vanish behind a curtain of cosmic dust. Once they found them, the next question became unavoidable. Were these objects truly that far away, or were they just masquerading as ancient galaxies? Even the lead scientists admitted that if only a handful of these candidates turn out to be real early galaxies, cosmology itself will need an upgrade. But speculation only gets us so far. The real answers will come from spectroscopy, splitting a galaxy's light into a rainbow to read its molecular fingerprints. This is where the universe either confesses or keeps its secrets. And whatever the truth is, the implications are enormous. Confirmed galaxies this early would mean our theories about how matter clumps together are incomplete. If they're not galaxies, then we've just stumbled on to a brand new cosmic phenomenon, one that shaped the universe long before galaxies rose from the dark. Before 2022, our farthest galaxy trophy went to GNZ 11, spotted by Hubble. It was a record worth celebrating. Hubble, with its 2.4-meter mirror, pushed humanity's vision deeper than anyone thought possible. But even Hubble had its limits. Then Webb arrived, massive, powerful, and tuned perfectly to infrared, the very light that ancient galaxies whisper across the cosmos. It didn't just surpass Hubble's record, it obliterated it. One of Webb's early triumphs was a galaxy known as JWST Z14-0, confirmed with a redshift of 14.32. And if that wasn't enough, along came MOM Z14, breaking the record again with a redshift of 14.44. Each jump pushed our gaze farther into the universe's childhood. So far, we're now practically looking at cosmic infancy. But what MOM Z14 revealed was even stranger. This galaxy is tiny, about 500 light-years across, a speck compared to the Milky Way, yet it shines like a beacon. According to every model we have, early galaxies should be faint, quiet, struggling to form stars, but MOM Z14 is bursting with them like a cosmic fireworks finale happening at the dawn of time. And then came the most confusing twist. There is no supermassive black hole. Galaxies that form stars at this rate almost always have an enormous black hole anchoring their center, shaping their growth. But MOM Z14 is missing one entirely. It breaks the rules we thought were unbreakable.
When scientists analyzed the galaxy's light with Webb's spectrograph, they found it overflowing with nitrogen, far more than expected. This chemical signature matches what we see in some of the oldest star clusters orbiting the Milky Way, hinting that MOM Z14 forms stars in extremely dense, ancient-like environments. And that's not just surprising, it's a cosmic curveball. Galaxies born this early in the universe's timeline were supposed to be simple, Just clouds of hydrogen and helium slowly figuring out how to shine. But MOMSI 14 throws that idea out the window. Its chemical makeup suggests something shocking. Whole generations of stars had already been born, lived brilliant lives, and died long before this tiny galaxy came into view. Suddenly, the cosmic clock looks wrong. Maybe star formation began far earlier and in far more places than we ever dared to imagine. And this leads to an even bigger question, one that scientists are whispering more loudly with each new JWST image. If MOMSI 14 exists, how many more are hiding out there? Before JWST launched, we thought galaxies from this era were unicorns, rare, faint, barely detectable. Now, they're showing up again and again, scattered across Webb surveys like sparks from some ancient cosmic fire. Astronomers even have a nickname for these tiny, bright anomalies, little red dots. It's starting to feel like MOMSI 14 might be the record holder for now, but only until the next JWST observation drops. And that realization is electrifying, because the deeper we look, the more the universe seems to wink back at us, as if saying, "You still have no idea." If many galaxies in the early universe were this bright, this dense, this chemically evolved, then our models aren't just off, they're missing entire chapters. Does MOMSI 14 challenge cosmology? Absolutely. Our theories tell us that young galaxies should grow slowly, remain dim, and stay chemically simple. MOMSI 14 breaks every rule. It's fast-growing, it's luminous, and chemically, it's way ahead of schedule. But this doesn't mean our theories are useless. They're just incomplete. MOMSI 14 is a breadcrumb, a hint that the early universe may have been buzzing with activity, bursting with stars, and evolving at a pace we never anticipated. And this is only Chapter 1. Soon, the Nancy Grace Roman Space Telescope will join the hunt. While JWST peers deep, Roman will scan wide, huge swaths of sky with exquisite sensitivity. Together, they could uncover hundreds, maybe even thousands of galaxies like MOMSI 14, each one a tiny beacon from an era when the universe was still learning how to exist. But until then, MOMSI 14 stands as a small miracle, a bright spark from an era where light itself was new. And the more we study Webb's discoveries, the more the universe seems determined to surprise us. Some scientists have taken the data in an astonishing direction, the possibility that our entire universe might exist inside a black hole. A new study revealed that most galaxies seem to rotate in the same direction, a subtle but significant pattern. When astronomers traced the curves of their spiral arms, they found a preference in spin direction that shouldn't exist. In a truly random cosmos, galactic rotation should be a coin toss. Half one way, half the other. But that's not what the data shows. This unexpected alignment isn't just weird, it contradicts our existing cosmological models. And one group of researchers believes it might be a clue that our universe is not a universe in the traditional sense, but rather the interior of a massive black hole. To make sense of that, we need to revisit what happens when matter collapses under gravity. A black hole forms an event horizon, a one-way boundary where information disappears forever from outside view. But what's inside that boundary remains a mystery. And that's where black hole cosmology, or Schwarzschild cosmology, enters the scene. It proposes that the Big Bang wasn't an explosion in empty space, but the birth of a new space-time inside a black hole formed an apparent universe. In this model, the singularity at the beginning of our universe isn't an origin point, but a bridge, a collapse that created a brand new internal cosmos. Which leads to a staggering implication. Every black hole in our universe could be a gateway to another universe. A cosmic family tree where universes give birth to new universes through black holes. It could even explain why the laws of physics seem fine-tuned for life. Universes that produce long-lived black holes may be more likely to reproduce,
evolving constants that favor stability. In a strange way, the cosmos might be participating in a kind of natural selection. And according to the scientists studying these clues, this black hole universe model just might help solve some of our greatest cosmic mysteries. Black holes are some of the strangest objects in the cosmos, and one of their most surprising features is their enormous entropy, a measure of disorder that, in this context, reflects the staggering amount of information they contain. Some scientists argue that this might not be a coincidence at all. It might actually be tied to the amount of information stored within our entire universe. And then there's torsion, a concept that appears in extended versions of general relativity, such as Einstein-Cartan theory. Torsion accounts for the tiny intrinsic spin that particles possess. And in extreme environments, that spin could literally twist space-time itself. Some theories propose that this twist could create a powerful repulsive force when matter gets compressed to unimaginable densities. If that's true, it could mean that instead of collapsing into an infinitely tiny point, a singularity, a black hole might actually hit a kind of limit. And at that limit, the core could rebound in a massive, violent expansion. In other words, a big bounce. Imagine that. Instead of the universe beginning from nothing, our own Big Bang might have been the explosive rebound from the heart of a black hole inside another universe. According to this idea, universes don't just appear, they reproduce. Each black hole becomes a seed, and each seed spawns a new cosmos. If that's true, then the story of existence is one never-ending chain of cosmic rebirths. But the mysteries don't stop there. Another puzzle comes from something astronomers have noticed in the distribution of galaxies across the sky. On the largest scales, instead of being completely random, some structures appear to line up along a particular axis, almost as if the universe itself has a preferred direction. This phenomenon, known as cosmic anisotropy, contradicts the long-held cosmological principle, which assumes the universe looks the same in every direction. If this alignment is real, it could point to some hidden physics governing the shape and nature of our universe, perhaps even tied to the way a universe forms inside a black hole, or how forces behaved during its earliest moments. And still, the evidence piles up. The discovery of massive, mature galaxies appearing just a few 100 million years after the Big Bang continues to baffle astronomers. These galaxies shouldn't exist yet. They're too big, too bright, and too evolved for such an early cosmic era. Of course, the black hole universe idea is just one possible explanation. There might be simpler answers too. Maybe some of our earlier measurements are off, especially when it comes to the speed at which the Milky Way rotates. If our own galaxy's motion has been misunderstood, then maybe we've misinterpreted other cosmic signals as well. But regardless of the explanation, one thing is clear. The universe is far stranger than we ever imagined. These unexpected galaxy rotations and puzzling observations are forcing astrophysicists to take a second look at some of our most fundamental assumptions about reality. What about you? What do you make of all this? Share your thoughts in the comments below. And if you love exploring the mysteries of space, don't forget to subscribe to Territory. After all, this is your space.